Hey guys, welcome to the channel, and it's unfortunately become abundantly clear that I now need a shredder to work with the injection machine. Initially I thought what I could do is just take some filament, cut it down like this, or into these little granules, let's call it. They're not so small over here, but obviously I did this by hand. So the next project was actually going to be a granulator to take 3D filament and make little pellets and then use that in the injection machine. And obviously the advantage of that is you got your color, you can just buy the filament as you want and snip it up and use it. But it turns out that is not ideal, and the reason for that is obviously the cost, although it is pretty difficult to get the pellets and or the normal injection pellets. And another thing is that the viscosity of these 3D printed filament is too high, which I actually learnt the hard way. In other words, when you try to print this stuff, or not, sorry, I keep saying print, when you try and inject this stuff, it's quite thick and doesn't flow that easily, and that is because of added additives that they put into the filament to try, obviously it's because it's made for 3D printing, for adhesion, to stick to the layers and that, and this is stuff that you don't actually want for the injection molding process. You can sort of get around it by increasing the temperature, but obviously the downfall of that is when you're using a mold that's 3D printed, you're trying to keep the temperatures as low as possible so as not to damage the mold. So it looks like the granulator is maybe a future project, but once again it's not ideal. I did get some of these pellets. They're polypropylene, which seems to be the ideal plastic, and maybe somebody can answer this question to me or for me. Little pellets like this. I managed to get a sample batch of them, quite a lot, but I am battling with it. I'll actually make another video on all the lessons I've learned with this injection molding. I did some tests. This is olive oil, the float test, just to make sure it is polypropylene, which it is. But interesting enough, when you actually print or when you inject something, the injected item sinks, but the pellets float. So that's interesting. But to start off with, I took just some recycled plastic, like these lids over here, which you can see in the top here. I don't know if you can actually see that, but there's a 5 there and a PP, polypropylene. So I cut that up into little pieces to basically come up with this type of situation, but it does take an extremely long time to do this. So that's where the next project starts, and it looks like I'm going to need a shredder to take this sort of plastic, shred it up, and then use it in the injection machine. And it's actually strange that this plastic, the recycled plastic, I don't know, I'm getting a lot better results out of this plastic than the actual plastic that's let's call it virgin pellets that are used for injection molding, or specific injection mold grade pellets. So yeah, some lessons to be learned there as well. So what I've done is I've gone to the precious plastic design, and I'm going to use that design. What I have done is I've scaled it down by 50% because I don't think I need a grinder that, or a shredder that big. But what I was initially going to do is just take a round bar, put the blades in there, weld them on, and then that was going to be the main stack for the shredder. But I tried to make the blades myself, and this is the blade that I made myself, drilled a hole through it, got little blades, but you can see that that hole is actually not in the center there. So it's become abundantly clear that this will be a very arduous task to try and make 9 or 10 of these little blades, and it's not really going to be worth it, because as usual I 3D printed a few of them, and I was going to use that as the mold or the stencil to make these things. So yeah, so I've changed it. I'm going back to the actual design, which is a hex shaft, which I managed to get hold of. I'm going to weld a spacer on the end of it, and then the blades are just going to obviously slide on to each one like this. I'm not going to do it all, and they'll be at an angle so that they'll be sort of a, reduce the the stress per tooth as it goes through, and it just carries on going like that until eventually you've got your stack that's going to go on there. What I've seen on the precious plastic design, so I'm going to go into a lot of detail here. I was going to make this a few episodes, but I think I'm going to make it one long video, so I hope you stick to the end to see if this whole thing actually works. So at the end of the day, I took these and I found it, and then I got myself a hex bar. This is a 17mm hex bar, because remember I scaled it down, and I managed to find a place that's going to laser, or did laser cut this stuff out for me. So I laser cut this out of wood here. This is the spacer, this is the comb that's going to go on it like that. So it actually sits, those two things sit together like that, and it forms a little spacer there, and then the tooth will come across like that, grab the plastic and shear it off like that as it goes through. So I got the 3D or the laser people, and they managed to cut these things out for me. I mean, that came out pretty nicely. Here's the spacer, and I'll show you the teeth just now because I've already put that whole stack together in a test format. But error on my part, obviously just gave this to the guys, you know, obviously not having done this before, and got the stuff back. Definitely worth it. A lot less effort than making this tooth yourself, or these teeth yourself, and these components over here. But 4 hours later of sanding, or not sanding, rather filing, I eventually got these things to fit onto this hex bar over here. So obviously the tolerance wasn't quite there that I gave to them to cut out. So I've changed the design a little bit, and this is what I've come up with. At the moment it's 3D printed and metal stuff. So I've got two 10mm plates on either side, and these 10mm plates are the same plates that I used on the injection machine for that top bracket, if you remember that. Then I've got these block bearings on either side over here. Got the hex bar that's going to go through the center, and I've got the teeth here, and you can see the teeth are sort of spaced out or in a configuration to try and minimize the amount of torque required to pass through each comb when it cuts the plastic. Then all the combs go together on the back side over there with two bars that are going to go through there and hold them basically flat against here, and another plate will go on here. So if you look there, the actual, it'll turn, but it's going to be a lot of torque, as you can see, required to turn this and cut this. I mean, you're not going to go like this and just cut it with your hand. So that's why I say stick around to the end. Let's see if this thing actually works. Now, to actually make this part over here, which is going to hold, because obviously that's a 3D printed shaft at the moment, I'm going to take this shaft, I'm going to turn down the end over here to 15mm to fit through the bearings, and the one side is going to go onto the motor, and the other side is going to go also 15mm, step down to 14mm. It's going to have an M4 thread attached to it over there, which I don't know if you can actually see it over there, which I don't actually see them doing on the precious plastic design. And then I'm going to take this piece of metal, and this piece of metal comes from the cut out of the bottom plate of the injection machine. When I actually did that with a hole saw, this came out here. I'm going to obviously open that hole up. That's going to go on here as a spacer. It's going to be welded on to the end part here. The bearing is going to go through there with a thread on that side, and that is going to allow, or sorry, this space is going to go on this side here. Then each one of these teeth will go on. This will then go through the bearing, and this nut over here will compress all these teeth over here against this end bar here. And that is what I think they call compressing the stack. So these teeth will actually be under compression against from the side over here. So that when they turn, there will be no movement with the teeth that way. And hopefully that's going to solve some of the problems I have over here. Although I don't really think it's going to be a problem to move here. Well, I think the idea is that because plastic can get stuck in between these teeth, you can slightly move the orientation to the left or to the right, and then it's going to catch on the comb. So that compression will actually compress the stack to prevent that from moving. I could have missed that on the precious plastic design, but I don't see where they're doing that. So that's what I'm going to do to make sure that obviously works. Like I said, and there's going to be a plate across here, and the motor is going to connect on this side to turn everything. And obviously there'll be some sort of a funnel system here, and the plastic will come out the bottom. So the first step we're going to do is go over to the lathe and make this bar so that it can fit the teeth over there. Before I head over to the lathe, let's go over the actual design of the shaft itself. So this is the part that's going to connect to the motor. There's the spacer that's going to be welded on, the hex shaft, another part that just goes through the bearing. Then there's going to be a 14mm diameter turn down over here to fit an M14 by 1.5mm pitch. It's going to be there, and it's going to be 1742.5, 114mm to the end of that spacer over there. And then I've given myself quite a bit of space here, 100mm, just to connect to the motor. I can cut that off a little bit later. So let's go over to the lathe and let's make this. It's now time to make this plate over here, that where the bearings actually mount onto. So to do that, obviously this is what the plate's going to look like before. It's got the center hole and the two holes on either side where the bearing goes into. It's going to be threaded with an M12 thread over there, and then the two holes on either side over there that are going to actually hold the comb that goes on the side there for the blades to go through. Now to do that, remember I made these plates, so I'm going to use these plates over here, and I've created another 3D print of this, a drill pattern for this, so that I can just basically put that on the top over there and then punch the holes and drill them. So the first step is I'm going to put a piece of tape over there, and then I'm going to actually glue the two together and then punch the holes through. Okay, so lay the tape on the one side, like that. And I'm going to do the same for the drill side, or the drill pattern template here. Okay, I'm now going to use this glue that I use over here, normally use. It's got a catalyst and obviously the glue itself. Let's just make sure that everything is going to be okay. Let's get it like that, or okay, it looks like this is the best orientation. So I'll just put a bit of this glue on here. Doesn't have to be a lot, it's just to hold it in place for the basically the transferring of the hole pattern. Okay, well, there we go. So what I normally now do is I use a punch and a hammer and then obviously mark the holes and then drill them. But this time I'm actually going to try and just use a drill bit, and I'll just drill through here, and then obviously the drill will make a mark on the bottom there as opposed to using the punch. Okay, and let's see if that works out. Okay, I think that worked quite well. There's there are the drill hole or the marks, you can sort of see them there. And now I'm going to move over to the drill press. So I've had to set up a little bit of a MacGyver setup here with a block of wood underneath and then the side plate clamped to that because my vise is not big enough to handle it or fit it in directly. So I'm going to first drill the two 5mm holes. Now it's time for my least favorite tool, the hole saw, for that big center hole that's got to be drilled in there. Okay, at the end of that, that's what it looks like. Okay, after that, I've mounted the plates, as you can see on the side. Also tapped to the holes over here, and then they will fit this bearing on using these bolts over there. So now I've got the shaft mounted in here with the nut on the end over here, which I'm going to tighten up completely, and then just to make sure everything sort of turns. It won't really turn yet because not everything's in line, but the idea is now to move this nut. So I'm going to turn it back like, let's say, 3 or 4 turns, and I'm going to knock it in, maybe a little bit further than that. So what that'll do is it'll allow me to tighten this nut and put load onto the actual stack itself, moving this way, and keep everything tight. So I've got that little bit of space to move on that side there. So to do that, I'm going to use this ring over here, which is going to go onto the shaft on this side here, and it's going to be welded there, so permanently fixed there. This will be tightened and pushing the stack against this ring over here and allow for the preload to occur. So this is then going to go on this side here, which let's bring that into the camera here. So that'll go in there like that, and then it'll be welded in on that spot there, and then allow for the preload to occur. Inside here will be a little spacer, which will then push against from the inside of the race of the bearing onto the first spacer on the stack. So now I'm just going to mark where this spacer goes over here, or this preload ring, let's call it that, on the left hand side, and then that's going to be welded into place. So this is what the ring looks like from the other side, and I'm actually going to put this in the vise like this and weld it from the top, just to make sure that everything stays 100% in place. Okay, I've now welded the spacer, or this pressure plate, let's call it, onto the end of the shaft here, where the actual teeth themselves will be pressing against. Now I'm going to go to the lathe. I'm just going to make sure that this is 100% perpendicular to the shaft itself, and then work the shaft from the other side so that it will fit through the bearing on that side. Okay, that's what the shaft looks like once completed. Yeah, there's the pressure plate, let's call it, on that side, or as I'm calling it, and then the shaft on this side. So now I'm going to just do a reassembly of this quickly to see how it's all going to fit together, and then move on to the next step. So let's just put this all together again quickly. And it's binding in 1 or 2 places, but there we go. And it'll turn like that. And I think the binding is caused by the fact that this is not supported yet. So the next step will be to put these side supports on here. As you can see, that needs to come out quite a bit to get everything aligned. So I'll do that next. I'll just drill the holes through there, tap them, and then the plate will go on that side, and a plate will go on that side, like that. But I'll do that off camera to try to save a little bit of time, because this video is taking quite long now. and when I come back this will be already inserted and tapped holes on that side so that this can actually fit together, and these things will be properly aligned so that this will turn a lot easier. Okay, at this part of the build I've put the side plates onto the actual frame here itself. I've got the comb installed, and now I'll probably take it apart again to put the teeth on here, and then so that'll fit in there like that, and I can work out the spacer required for there to give the correct compression on the stack against this pressure plate at the back here. So I'm going to do that next. Okay, after quite a struggle I got that back in. Basically I had to take this whole plate off here again and do a whole lot of stuff, so it was quite a battle to get in. So now I need to work out the gap between this little spacer here, or the race of the bearing, and the first spacer inside the actual unit itself. Okay, according to my calculations, I'll need a 12.5 spacer between this race over here and the first spacer on the stack itself. So I'm just going to go to the lathe and make that quickly. To make the spacer I'm just going to use a scrap piece of steel. It's already got a little bit of a hole through it, but I'm going to drill it, bore it, and then cut it down to size. Okay, with the spacer installed, everything seems to turn nicely. And build some sort of protection over here, but I may just build this out of wood or something just to speed this project up, just to test it and see how it'll work with actually shredding plastic. So we'll do that in the next. Okay, now I have painted the whole unit. So I painted the side plates and everything. I haven't painted the inside because obviously I don't want paint contaminating the plastic when it gets shredded, but everything is in there. It does turn, and I think I'm going to stop this video here and let's call it part 1. And if you do find value in this type of thing, please consider subscribing. It doesn't cost you anything, and like and comment. I'd like to hear from you guys and what your opinions are. In part 2 I'm going to motorize this, so we're going to put some sort of a drive chain here or belt chain here going to a motor, and I think it's going to be a DC motor at this point with a drive system that I'm going to obviously develop myself, and we'll see how that goes and see it actually working in part 2 of this series. So guys, thanks for watching, and I'll see you in part 2.